Okay, so following on from my previous video about potential dividers, this was also another question that the same student brought to me that they got a bit stuck with, also similarly on potential dividers, except this time with a bit of a different twist. So again, another really great example of an A-level type electronics question, so I thought let's give it a go and see if we can find an answer. So to begin with, let's read the question. Two resistors, X and Y, are connected in series with a power supply of EMF 30 volts and negligible internal resistance. The resistors are made from wire of the same material, the wires have the same length, X uses wire of diameter D and Y uses wire of diameter 2D. What is the reading on the voltmeter? Well, to begin with, we can see again that this is, as I mentioned, a potential divider question. So to begin with, let's go through a quick recap of how we get the equation for a potential divider. So for the voltage across X, using Ohm's law, we have that this is equal to the current through the resistor X times by the resistance of resistor X, IRX. Now the current is the only thing that we don't know in order to find V. To calculate the current going through resistor X is the same as the current going through the whole circuit because it's a series circuit. So we can do Ohm's law for the entire circuit. V in is equal to I times by RT, where RT stands for the total resistance. RT is going to be equal to Rx plus Ry. Therefore, we have that V in is equal to I Rx plus Ry. Rearranging for I, that gives us I is equal to V in over Rx plus Ry. And again, like last time, substituting this value for I now back into our original equation, we get out that Vx is equal to V in times by Rx over Rx plus Ry. So hopefully this makes sense. If you want to see me go through this again, this is exactly the same as the last upload, so feel free to have another check through this again, but this gives us the exact same equation of a potential divider, where the potential through resistor X is equal to the division of the resistance of X over the total resistance in the circuit. Okay, fantastic. Now, the only problem with this is we don't know what the resistance of X is or the resistance of Y is. And the way that we need to figure this out is with a trick. And the way to spot what you have to do is through careful reading of the question. The question says the resistors in the wire are made of the same material with the same length and different diameters. So what we should be doing is thinking what ties together length, diameter, or something to do with diameter, and the fact that it's the same material with resistance. Because we know this is the correct equation, so we must have some way of finding out resistance. Well, the trick here is to use resistivity. So to remind you all of the equation for resistivity, we have that rho, which is resistivity, is equal to Ra over L. R is resistance, A is area, L is length, rho is resistivity. All right, fantastic. Well, going back to our equation, we're told that the resistors are made from wire of the same material, therefore rho X is equal to rho Y. They have the same resistivities. On top of that, we're told that the same length, so Lx is equal to Ly. Okay, well that's useful. We're then told X uses wire of diameter D, Y uses wire of diameter 2D. Well, putting all this stuff into our resistivity equation, since we know that rho X is equal to rho Y, what we can say is that Rx AX over Lx is equal to Ry AY over Ly. Because we've said that the resistivity of these two wires are the same, Therefore, everything on the right for x must be equal to everything on the right for the y. On top of that, we also know that Lx is equal to Ly. We're told that the length is the same. So using that, we can rewrite this equation as, if we use the eraser here, we can get rid of this Ly and say because Lx is equal to the Ly, we can also write this as Lx. And now we have 1 over Lx on both sides of the equation. So if we times this Lx, if we times the top and bottom of this side by Lx and times the top of this side by Lx, what we can do is just cancel that out, cancel out the Lx's. And we're left with this. We're left with Rx Ax is equal to Ry Ay. Okay, fantastic. What we can now do is say that Rx, or let me triple check which way round will be easier to do it. Let's figure out what Ry is actually, because then we only have to substitute one thing in later. Say that Ry is equal to Rx Ax all divided by Ay. Fantastic. We've now got a relationship for y in terms of x. Okay, brilliant. What we can now do is calculate what the ratio ax over ay is. It's the ratio of the area of x over the area of y. Well, x uses wire of diameter d. So if we put this in an equation, we'd say that area, assume that the wire is a circular wire, right, as you'd expect. A is pi r squared. And we know that r is equal to d over 2. So it's equal to pi d over 2 squared, right? Which we can rewrite as pi d squared all divided by 4. That's for ax. Now how about for ay? For y, we are told that it has a diameter 2d. Oh, put rx back there. So what we get is ay is equal to pi r squared again, which is equal to pi 2d over 2 squared, aka we cancel the powers of 2, which is equal to pi d squared, right? Fantastic. Let's substitute these values back into here. We have that this is now equal to rx pi d squared over 4 all divided by pi d squared. Well, we can really easily see we cancel the pi d squareds and we're left with rx over 4. So we can now say that ry is a quarter of rx. Cool. Substituting that back into our original equation now, all the way back up here, saying that ry is rx over 4, we can now get, if we move up here, vx is equal to v input rx divided by rx plus rx over 4. Now this is equal to, if you think about this, rx plus rx over 4, this is equal to 1.25 rx. I know mathematicians won't like me referring to it like that, but personally for me that makes it a bit easier. 1.25 rx, because we've got one full rx and a quarter of rx. Now we can cancel the rx's, and what we can see is that our value of Vx is just equal to the input voltage, V in, divided by 1.25. If we look at what our input voltage is, 30, we get that that's equal to 30 over 1.25. And if I pull out my calculator, I get that answer out as 24. Check back and see if that's one of the answers. Yes, it is. And it turns out that that is the correct answer from the mark scheme. So hopefully that makes sense as to how we go through about answering this question. This does look really complex and really messy. I'm sure it does. But to recap of how we did it, we came up with the potential divider equation. We then came up with a relationship between the resistance of wire X and the resistance of wire Y. We did this through using the resistivity. We equated the two resistivities as we knew they were made of the same material and had the same length. We then found out what Ry was as a ratio of Rx due to the ratios of areas. And then we substituted that value of Ry in terms of Rx back into our original equation to get out our answer of 24. So hopefully that was helpful. Please do like, subscribe and share with anyone else who you think might find this helpful as well. And stick around for any further questions that I do in the future.